In this video, we are going to look at solving vector problems involving collinearity. This example here, ABCD is a parallelogram. Vector AQ equals to 2 vector R and PA equals to vector S. Q is a point on AB such that the ratio of AB is to QB is 3:1, and therefore the ratio of AQ is to QB is 2:1. Since AQ is equals to 2 vector R, QB will be equals to vector R. Also, we know that X is the midpoint of PB, and therefore the ratio of PX is to XB is 1:1. Since this quadrilateral is a parallelogram, we know that DC will be equals to 3 vector R. And we also know that the diagonals of a parallelogram bisect each other, and we will have CP equals to vector S as well. Transfer all the information onto the diagram, we can now find vector BC. Now vector BC, we have to go from the most direct path from B to C, which is BA plus AC. Early on, we already know that BA is actually equals to negative 3R, and AC will be equals to negative 2S. To find vector BX, we can go from B to X, or we can just simply use the ratio that BX is half of BP. To find BP, we will have BA plus AP, and BA is given by negative 3R, and AP will be negative S, and so we have negative 3R minus S, and hence vector BX will be equals to half of negative 3R minus S. We are asked to show that vector XC equals to negative 3/2 multiplied by vector R plus vector S. So in order to find vector XC, we will go from X to B and B to C. And we realize that earlier on we already have vector BX and vector BC. So we will just put in vector XB here, which is the negative of vector BX, plus vector BC, which is and simplifying, we will have 3/2R plus half S minus 3R minus 2 vector X. And here we will have negative 3/2R minus 3/2S. Shown. Finally, and most importantly, we are asked to show whether points Q, X, C are collinear. This means that we are asked to show whether points Q, X, and C lies on a straight line. In order to do so, we have to show that QX is parallel to QC, or QX is parallel to XC, or QC is parallel to XC. Looking at the questions, we already found XC in part B. So we will need to find either QX or QC. Now XC found earlier was negative 3 over 2r minus 3 over 2s. And let us now find vector qx. We can do so by going from q to b and b to x. So vector qb is equals to r, and vector bs from a part 2, we have found that it is equals to half times negative 3 vector r minus vector s. And simplifying it, we will have negative half r minus half vector s. To show that these two vectors are parallel, xc over qx must give us a constant. So we will now compare the coefficient of vector r. So xc over qx will be negative 3 over 2 divided by negative half, which will give us 3. And comparing the coefficient of vector s here, we will have negative 3 over 2 divided by negative half as well, which will give us 3. Therefore, vector xc over vector qx is equals to 3, and vector xc equals to 3 multiplied by vector qx. This will show us that xc is parallel to qx because they are equal vectors multiplied by a scalar multiple. And since they share a common letter x, they are not only parallel, but points Q, X, and C are collinear. And we have proven that QXC are indeed collinear.